start with some introduction to this course. So Calculus 3 is what the last course in Calculus series. So it depends on what you learned from Calculus 1 and Calculus 2. We need the background that you have in Calculus 1, Calculus 2. This course dealing with integration and differentiation. Integration, which comes from Calculus 1, and differentiation comes from Calculus 1, and integration comes from Calculus 2. But we will generalize these principles that you learned from Calculus 1 and Calculus 2 to what? To vectors. So mainly, this course has two components. Has the vectors and the vector valued functions. So LO1, in LO1 we'll discuss the vectors and their properties, the operation on vectors, the two product, cross product, the norm of vector, the direction of vector, etc. Then we will be introduced to what's so-called vector valued functions. This is a function. These functions are functions, but in the same time they are vectors. After that, we will leave the vectors aside, and we'll be moving to what's so-called several variable functions, several variables functions, which are functions, but depends on more than one variable. So we're not talking anymore about f of x. We'll be talking about f of xy, f of xyz, etc. And because of that, because we are talking about several variable functions, we will see how to differentiate these functions. Afterward, will be introduced to how to integrate such functions. We'll be introduced to double and triple integrations. So instead of talking about single integration, we will talk about double integration if this function has two variables, and we'll be talking about three integration if we are talking about a function which depends on three variables. So as you can see from the CDP, or I think you have the feeling that you need good background from Calculus 1 and Calculus 2. So if you don't have this background, you might need to return back to Calculus 1 and Calculus 2 and take a review for an hour or so to be able to deal with Calculus 3. Okay, about the grading, we have I think it's similar to what we did in Calculus 2. We have two tests. The FOA carries 30% of the grade. Test 1 and test 2 carries 2.5 each, 22.5 each. The quizzes carries 15%. The homeworks carries 5%, and MATLAB assignments carries 5%. Do you guys have any question about the course itself? Okay. Also, in this term, we have a new strategy to follow. There is a primary instructor, there is a secondary instructor. So I'll be the primary teacher for this course, but there are two other teachers which will be doing like reviewing session, solving exercises, and etc. So mainly I will be what covering the material. The other two instructors will be what solving problems, review the sessions, answering any question if you have any question about that. And of course, you can contact me if you have a question. If you have any question about what the last session. Okay, so let us start talking about vectors. So in math and science and engineering, we have two quantities to deal with. We have scalar quantity and vector quantity. There are quantities which are scalars, and there are quantities which are what? Which are vectors. So what are the differences between scalars and vectors? How do you know that the quantity that we're dealing with is a scalar or a vector? The key is one word. We have one word. Direct. Exactly. Excellent, Fatima. Yes. The key word is direction. Yes, direction. This quantity has what? Has direction. The scalar does not have what? Have a direction. So if we want to talk about vectors, we need to determine its direction. The scalar does not have what? Direction. For example, if we're talking about time, there's nothing called direction for time. What I mean by direction, I mean, we cannot imagine talking about like 2 seconds east, 2 seconds west, or 2 seconds above, up, or 2 seconds down. So time is what is quantity. The mass, the weight, all of these quantities are what? Are scalars. We don't need to determine there's no direction for such quantities. But when we're talking about your position, the position is a vector quantity. Why? If you are sitting in a room and you're trying to determine your position, you will say I'm sitting to the right of this door, next to that door, behind the main gate, etc. So when you say such things, yes, when you say such things, you are talking about what? About vectors. Also, another example. Yes, exactly. Maryam? Velocity. Force is what? M times A. A is what? The acceleration is what? It also is a vector. Force is what? Also a vector quantity. What about speed? Speed, it's not, yes, it is a scalar. It is a scalar. The speed meter in your car reads what? Reads scalar. It does not read what? Does not read vector. But when talking about velocity, yes, we're talking about what? Vector quantity. Just hold a second. Okay. So now we have two types of vectors that we will deal with. Vectors in a plane and vectors in space. Vectors in planes and vectors in spaces. What is the difference between these vectors? Simply, in simple words, this is 2D vectors, two-dimensional vectors. Vectors in space, this is 3D, three-dimensional vectors, but in 3D. Since we are talking about 2D and 3D, I mean, it's easy to guess that, you know, the vectors in planes has what? Two components, where vectors in spaces has what? Has three quantities. Yes, Ali, exactly. So vectors in planes has what? Has two components. In this case, we use this notation. Either we write V as A and B in this bracket, the vector bracket, or we're dealing with I and J. I think you guys know what is I and J. In 3D, we use this notation. V is A, B, and C. Or we use the notation I, J, and K. Now, what is I and J? This is the plane. This is the XY plane. I is what? Is the unit vector toward what? Toward toward the x-axis. It's a vector of length 1 toward the positive x-axis. J is the unit vector toward what? Toward the y-axis. Now, what about the vectors in space? In space, we have what? I, j, and k. So we're talking about I, j, and k. We have 3 unit vectors. I toward the x-axis, I is the unit vector toward x-axis, j toward the positive y-axis, and k toward the z-axis, the positive z-axis. So these are the notations for what? For vectors in planes and vectors in spaces. So now we're talking about operation on vectors. Operation on vectors. Or introducing the 2 main aspects of any vector, the norm and the direction. How to find a norm of a vector or the direction of a vector. Now, if we want to sketch, for example, the vector 2i plus 3j, I think you have an idea how to do this from physics 1. This is the vector which has what? 2 components, 2 toward the positive x-axis and 3 toward what? The positive y-axis. 2 toward the x-axis and 3 toward what? The positive y-axis. So this is our V. This is the vector V. I think I have a connection problem, so I have to close the camera. Now, what is the norm of this V? By norm, we mean what? The length of this V, the magnitude of this V. How to find what? The magnitude, the length of V. So we're talking about this distance from the origin toward the end of this vector. What is the distance between these points? Well, it's not hard. If you would complete this triangle.
3 square. 6.
Yes?
It's root of 2 square plus 3 square.
Exactly. Excellent. Yes, exactly. So, yes, so exactly. So we're using what? The Pythagorean property For what? For right angles. This is what? This is 2 units. This is 2. And this is 3. Now we're using what? Using Pythagorean property. And the magnitude of V is what? Radical of 2 squared plus 3 squared, which is the radical of what? Of 4 plus 9, root of 13, yes. So the magnitude of V is the radical of 2 squared plus 3 squared. Now, instead of writing all of this, we use this notation. The magnitude of V, or the norm of V, is denoted by norm of V. So double bars on the right and double bars on what? On the left. This is how we denote what? Denote the norm of any vector by writing this. So I think now you can guess, if we have a V in the plane with 2 components A and B, how to find what? The magnitude of V. Then 2 squared plus 3 squared, this is radical of 13. But the point is what? We squared the first component and we squared the second component. So the norm of V is radical A squared plus B squared. Now, what about the vectors in the space? If we have 3 components, the same will happen. We squared A, we squared B, we squared C, and we take the radical, the square root for the whole what? The whole answer. So if V is a vector in the space with 3 components, A, B, and C, then the norm of V is this. For example, the magnitude of minus 2i minus 3j plus k equals to what? Radical of the square of minus 2. We squared minus 3. Now we squared what? The coefficient of k, which is 1. And add all of these numbers. This is 4 plus 9 plus 1. So radical of 14. Yes, exactly, Mary. Now, in order to define what is the direction of a vector, we need this to define what's so-called unit vectors. So what is a unit vector? I mean, you can guess from what? From using the name itself. Equal to 1. What exactly equal to 1? Which quantity equals to 1? The norm. The norm of this vector equals to what? Equals to 1. Any vector V of norm 1 is called unit vector. So if the norm equals to 1, then this vector called what? Called unit vector. If the norm is not 1, then this vector is not a unit. Is not a unit. The most famous examples for unit vectors, I, j, and k. I, j, and k are unit vectors. Why so? I mean, if you take the norm of k, this is the norm of what? 0, 0, 0 toward the x-axis, 0 toward y-axis, and 1 unit toward what? Toward z-axis. Now, find the norm of this vector. 0 squared, 0 squared, squared. 0 squared is 0, 0 squared is 0, and 1 squared is 1. Then the answer is 1. Yes, exactly, Hafsa. Yes. So this is a unit vector. Okay, which of these are unit vectors? Which of these vectors are unit? So in order to answer this question, we need to find the norm for each vector. For example, what is the norm for the first vector? Yes, 4 is a unit, Sheikh. Yes. So the norm of this vector is what? The radical of minus 2 squared plus 1 squared plus 2 squared. So this is what? 4 plus 4 plus 1, which is 9. Radical 9 is 3. How do we know that this is not a unit vector? The answer is not 1. If the answer is 1, then the vector would be what? Would be a unit. So this vector is not a unit. How about the second one? The norm of the second vector is what? 1 over radical 2 squared plus minus 1 over radical 2 squared plus 0 squared. 1 over radical 2 squared is half, plus minus 1 over radical 2 is 1/2, plus 0. 1/2 plus 1/2 is 1. So this is a unit vector. The third one, you can check that the third one is not a unit vector, and the fourth one is a unit. The fourth is a unit. Okay, so now why we need the unit vectors? It's very important to describe the direction of a vector. The direction of a vector, we need this definition to determine what? The direction of a vector. Okay, the direction of a non-zero vector v is a unit. So we cannot talk about a direction of a vector. I mean, the direction of a vector, of a non-zero vector, cannot be something different from what? From a unit vector. It should be a unit vector. So, for example, this statement is wrong. The direction, if you get, for example, during the test, the direction of v equals to 2i plus j, for example. This is wrong. It cannot be a true statement. Why? Because this is not unit vector. The direction of any vector should be what? Should be unit. Should be what? Should be unit vector. So now, how to calculate what? To calculate the direction. if we have a non-zero vector, how we can calculate the direction of this vector? Well, we use this fact or this proposition or if V is non-zero, then V over unit norm of V is unit. Is unit vector. If V is non-zero, then V over norm of V is unit vector. Why we need this? This proposition means that if you have any non-zero vector and you divide the vector on its norm, then you will get what? You will get a unit vector. For example, take V to be what? To be 4i minus 3j. Now, what's the norm of this V? The norm of this V is radical of 4 squared plus minus 3 squared. Which is what? Which is 16 plus 9. This is 5. Yes, 5. Now, if you divide V over norm of V, the answer must be a unit vector. Let us check. Divide 4i minus 3j by 5. The answer would be what? Would be 4 over 5 and minus 3 over 5 and 0. Now, what's the norm of this vector? Is what? 16 over 25 plus 9 over 25. 1. Yes, 1. So V over radical V is what? Is a unit vector. We use this example to what? To verify that this proposition is true. So all the time, V over norm V is a unit vector. Also, the direction of a vector V is also a unit vector. So how can we conclude something about that? V over norm V is a unit. The direction of V is a unit. So what does this imply? It implies that the direction of a vector V is the V itself dividing by its norm. So this is very important. The norm, the direction of a vector V is V over norm of V. So the direction of, for example, 3i minus 4j, before a second, we find the norm of this vector. The norm was 5. The norm was 5. So the direction equals to 3i minus 4j, and we divide the whole thing by what? By the norm. The norm is 5. So the final answer is 3 over 5 minus 4 over 5 and 0. This is what, this is the direction of this vector. Okay, now if the direction and the norm of a vector are given, how to find that vector itself? If the norm and the direction of a vector are given, how do we find the vector itself? So starting with the direction, we need to find what? To find V. We are given what? We are given the norm. This is given. And the direction. The direction is given. So what is the relation between these numbers? Or these vectors, scalars and vectors? How to find V out of these numbers, out of 1 and 2? What we can do in this case? I mean, if you multiply 1 times 2, if you multiply, yes, exactly, Fatma, yes, Hafsa. If you multiply 1 times 2, if you multiply norm V times V over norm V, if you multiply this and this, what would be the result? The result is clear. This will eliminate with this, and the answer is V. Yes, exactly, Fatma. So if you want to determine the V, the vector V, out of the magnitude and direction, just multiply what? Multiply the vector with the magnitude of this vector times its what? Its direction. So this is the norm, and this is the direction.